Hey everyone, and here the difference between the inductor exciting with AC voltage and capacitor excited with AC voltage. Now first case, when inductor is excited with AC voltage, now here let's consider current as a reference. So I is equals to Im sine of omega t. This is reference. Then VL of t will be, as we all know, that voltage across inductor is L into di by dt, which we have learnt in unit 1. In that L into di by dt. Now d of I of t, L into d by dt of this I will be Im sin omega t. When you differentiate it, then it will be L into Im into cos omega t. Again this omega comes out as a differentiation of omega t with respect to t is omega. So VL is L Im omega cos omega t. Here this one you can write as Vm. Then we will get as VL of t is equal to Vm into sine of omega t plus pi by 2. Why is cos omega t we can write as sine of omega t plus pi by 2. So VL of t is Vm into sine of omega t plus pi by 2. I is Im into sine of omega t. So I of t is Im into sine of omega t, means I at an angle 0. Next VL of t is Vm into sine of omega t plus pi by 2. So V of pi by 2. So this phase angle is pi by 2. Now Z. Impedance is V by I. Means VL of t by IL of t. It will be as V of, this phase angle is 90 degrees. Now this current phase angle is 0. Now phase difference will be pi by 2 minus 0, right? This 90 minus 0, so phase difference is 90. V is omega L Im. Here, omega L Im. And I is Im. Im get cancelled. Omega L is left. Omega L at an angle of 90 degrees. Omega L can be written as XL. So, Z is XL into pi by 2 we can write as cos 90 plus I sin 90. So Z is equals to XL into I, because cos 90 is 0 plus I into 1. Z is XL into I. Now this XL is known as inductive reactance. Whatever we got, this XL as omega L is known as inductive reactance, means the amount of resistance offered by the inductor to oppose the flow of AC current. Actually we all know that to oppose the flow of current it is resistance. In this AC current is impedance. In that impedance also if that inductor is opposing, then that resistance is known as inductive reactance. Okay, means if the inductor is there, then that opposition of AC current will be inductive reactance. If the capacitor is there, then the opposition of AC current will be capacitive reactance. So here this we can also write as it is the ratio of the voltage to current, XL. It is denoted by XL. XL is equals to omega L, which I wrote here. So omega is known as 2 pi f into L. Now XL and F are directly proportional, means it is in the form of y is equals to mx. So straight line format. Now if F is 0, means if frequency is 0, then XL will be 0, right? If XL is 0, now Z is equals to XL into I, we can write as V by I, right? VL by IL. So if XL is 0, means this part will be 0. Means numerator is 0, V is 0. So if frequency is 0, XL is 0, then V is 0, means short circuit. If frequency is infinite, XL will be infinite, means the denominator I will be 0, means open circuit. So if frequency is 0, means XL is 0, means 0 inductive reactance, means short circuit. If infinite frequency, then more infinite inductive reactance, then open circuit. XL varies directly with respect to frequency. Next, power we need to find. V of t into I of t, right? P of t will be, means Vm into cos omega t into Im into sin omega t, right? So Vm Im, this multiply and divide with 2, then 2 sin a cos p will be sin 2a, 2 sin a cos a will be sin 2a. So Vm by 2 Vm Im by 2 into sin of 2 omega t. This we can write as Vm by 2 as Vm by root 2 into Im by root 2. Vm by root 2 is Vmax, Im by root 2 is Imax. sorry, IRMS. This is max, mm means max, okay? So Vm by root 2 is Vrms, Imax by root 2 is IRMS. This is Vrms, IRMS. These two are RMS values, okay? P of t is Vi sine of 2 omega t. Now P average is 1 by 2 pi integral of 0 to 2 pi Vi sine of 2 theta d theta. So 2 theta d theta. So Vi by 2 pi into integration of 0 to 2 pi sine 2 theta d theta. Now integrate it, apply all that integral limits, then you'll get minus Vi by 4 pi into 1 minus 0. So power average is 0. So average power is 0 for inductor. If there is only inductor, average power will be 0. Means inductor will never consume true power. True power it will never consume. But imaginary power it will consume. Like in terms of I or J, that complex number will be there, right? That imaginary power it will consume, inductor. But pure power it will never consume. Average power is consumed by pure inductor is 0. Now, this is the graph. Here, Vm is V of t is Vm into cos omega t. Im is I of t is Im into sin omega t. So this we can write as sin of omega t plus pi by 2, right? So V of t is 90 degrees more than I of t. Voltage is 90 degrees more than current. That's why at 0 degrees, 0 plus 90, V of t will be 90. This is cos graph, this is sine graph. Because V of t is Vm cos omega t. So this is cosine graph, cosine curve. I of t is Im sin omega t. So this is sine curve. That's it. And here if we check, all values to substitute at 0 degrees, 90 degrees minus this 180, 270, 360 for V of t and I of t, as it is Vm cos omega t. So cos of 0 is 1 only, so Vm. So at 0 degrees voltage is more. So here if the current is reference, voltage is more. Voltage leads to the current by 90 degrees. If the voltage is different, then current lags the voltage by 90 degrees. Check here. Vm cos omega t, Im sin omega t. This is reference. So this one. Then Vm cos omega t, sin of omega t plus pi by 2, right? When current is reference, voltage is 90 degrees more. So voltage is 90 degrees more. This one will come. If voltage is reference, then opposite. Then current will lag in this way. Next, capacitor. When capacitor is excited by an AC voltage, then V of t will be Vm sin omega t. This is reference. This is reference. And in unit 1, we have seen a formula like I of t is equal to C into dV by dt. Current is C into dV by dt. I of t is C into d by dt of V will be Vm sin omega t. This sin will be cos omega t into omega. I of t C Vm cos omega t into omega. I of t, this omega C Vm will be Im. Here in this inductor case, here omega L Im is Vm, right? Then here omega C Vm will be Im. Z is equal to Vc of t by Ic of t. Vm sin omega t by omega C Vm cos omega t. Vm get cancelled. This one you need to substitute. Then 1 by omega C. This sin will be sin only. Cos will be sin of omega t plus pi by 2. So denominator is 90 degrees. Denominator is 90 degrees more than numerator. So when you do phase angle difference, this 0 minus 90 degrees. Minus 90 will be there. So 1 by omega c into cos minus 90 plus I sin minus 90. Cos minus 90 is 0. Sin of minus theta will be minus sin theta. So will be minus I. Z is equals to 1 by omega c minus I. 1 by omega c minus I. So Z is 1 by omega c can be written as omega c xc. 1 by omega c is xc. Capacitive reactance minus I. So X is capacitive reactance. Means when the inductor opposes the flow of AC current, then that resistance, how much resistance that capacitor will apply, how much resistance that capacitor will apply to oppose the AC current is known as capacitive reactance. It is denoted by Xc. Xc is 1 by omega c, Xc is 1 by 2 pi Fc, Xc is inversely proportional to F. Here X is inversely proportional to F, so like this graph will be there, and when F is 0, Xc will be infinite. Xc will be infinite means omega should be 0, right, denominator. I mean this, okay, wait, Xc is equal to V by I, right, because as it is Z, it is also a resistance only now, that's why V by I. If F is 0, Xc will be infinite, then V will be more, I will be 0, I is 0, open circuit. When frequency is 0, it is open circuit. When frequency is infinite, then the Xc will be 0. If Xc is 0, then V will be 0. V will be 0, short circuit. Now we need to find power. Same like this only for inductor also. V of t into I of t, Vm sin omega t, Im cos omega t, Vm Im by 2 sin of 2 omega t. Vm by root 2, Im by root 2 will be there. Means Vm by root 2 means Vrms, Im by root 2 is Irms. Sin of 2 omega t. When you integrate it 0 to 2 pi, you will get as 0. So power average is 0 for capacitor. So capacitor never consume true power. Will consume only imaginary power. Now at omega t is 0, 90, 180, 270, 360 you find V of t, and I of t also you find at 0, 90, 180, 270, 360 you find. Now as I already said, here V of t is reference, right? Vm sin omega t, I of t is Im cos omega t, means sin of omega t plus 90 degrees, pi by 2. So I of t is 90 degrees more, right? This is cos curve, Im. So our current is cos curve, voltage is sine curve. It is sine. So voltage is sine curve. Now in phase, as voltage is reference, current is 90 degrees more than voltage. So current is 90 degrees more than voltage. So current leads voltage by 90 degrees for capacitor when voltage is reference. Now when current is reference, now means when current is sine, if this is sine, then voltage will be cos, right? Current is sine, then voltage will be cos. Means cos means sine of omega t plus pi by 2. Then voltage will be 90 degrees more than current. Sorry. Now minus 90 will be there. Voltage will decrease, reverse. So voltage will decrease. If current is reference, as here voltage is always less, current is more. So here when current is reference, voltage lags behind current by 90 degrees. If voltage is reference, current leads voltage by 90 degrees. This is for capacitor. Thank you.